Hey guys, welcome back to the second video on hypothesis tests. This is the second problem that I made up. The average amount of hours a light bulb should last is 1500 hours with a standard deviation of 75 hours. Now what you guys should notice in this case, which is a little bit different than the other problem, is that the standard deviation was given almost immediately. Okay, and that tells you that, well, that doesn't tell you that it's a population standard deviation. The reason why it's a sigma and not an S is because nowhere have we discussed the sample yet. And so that's why it's a sigma. If it was an S, it would say we took a random sample of light bulbs and this is what we found. And that would make it S. Okay, so mu is 1500, sigma is 75. This automatically tells you that it's going to be a Z. In a random sample of 80 light bulbs, okay, the average amount of hours that the light bulbs lasted was 1476. So 1,476, even though they claimed it to be 1,500 hours. Is there sufficient evidence that the light bulbs last less than 1,500 hours? So in this case, they want you to test it at 0.05. We know it's a hypothesis test. We know that it requires 5 steps. Our first step is the hypothesis. This always needs to be a parameter. So mu equals 1500. When I say parameter, that means mu or p. HA, or some books call it H1, says mu is less than 1500 because that's what this part is trying to figure out. We're trying to figure out if it's going to be less than. The most important thing that you guys cannot forget is to define your parameter of interest. So you have to say where mu is, and then you just go back up here, let's get a different color, and just read what it says and just write that down. Where mu is the average amount of hours a light bulb should last. So I'm not going to write that there because I don't want to waste time, but that's what you need to write for your parameter of interest, okay? You have to tell the reader what mu is. Step 2 is our conditions. There's always 2 conditions. The first one is randomization of some sort, and the other one is to show approximately normal or normal, okay? So approximately normal or normal. So I wrote here, the stem of the problem states the light bulbs are chosen randomly, so in a random sample of 80 light bulbs. Okay, so let me just put down n is 80 and x bar is 1476. And since the sample size is 80, which is greater than 30 by the central limit theorem, we can assume this distribution is approximately normal. So large sample size tells you that the distribution will become approximately normal according to the central limit theorem. In the first problem, n was 6. I wasn't able to use this because n was small, so the problem did tell us that it was normally distributed. In this problem, it doesn't tell you it's normally distributed, so you have to say that it's greater than 30. So that's step 2. Step 3, our formula. As I said before, the formula will be Z equals this time because I have a sigma, okay? So I think it's 1476 minus 1500 over, I apologize, 75 over square root of 80. So let's talk about this for 1 second. Your formula is statistic minus parameter divided by the standard deviation of the statistic, which is also basically the standard error. Those are both the same word. So this is your formula, okay? You can use formula sheets for this. Z equals x bar minus mu over sigma over the square root of n. Great. We have these numbers here. We're going to plug them into our calculator. How do we do that? Well, you're going to press stat, go over to test, and hit the first one, z-test. Under z-test, remember why it's z-test. That's why it's sigma, 15, 1476, 80. The question says less than. You hit calculate, you press enter. If I'm going too fast, slow down, you try it yourself, okay? After that, you press enter, and you get a z-score of negative 2.86. So you go back here, and you have z equals negative 2.86. That's what all of this equals. Great. Now that's negative 2.86, I need a p-value. That's step 4. the p-value is always given right below. So p-value is this guy. It's really small, 0.0021. So your p-value is 0.0021. We know we will never write it like that. You should write it with notation. So since this guy is negative, I'm going to write down the probability of obtaining a test statistic this much or more extreme is that value. In other words, the probability z is less than negative 2.86 is 0.0021. Now, in the last video, I put a 2 in front of it. Well, that was because it was a two-sided. In this video, I don't care that I don't put a 2 there because it's only a one side. I don't care about the other side. It's just a less than. So that's how you do that, okay? The reason why it's less than this case, we have a, well, it tells you in the problem to test less than, but if we see a negative, it should be less than. So step 5 is our conclusion. Assuming HO is true, okay, then what are we going to do? Since the p-value, right, parentheses, is less than basically any conventional alpha, 0.05, we reject HO. We have sufficient evidence that it is that the light bulbs last less than 1,500 hours. It does last less than 1,500 hours. And less than, it does last less than 1,500 hours. Okay. If you did make an error accidentally, this would be a type 1 error. If we did make an error, it would be a type 1 error because we rejected, okay? If we did. So that's how we do this problem. And once again, slow it down, try the problem yourself, make sure you know how to use the calculator for this stuff, and remember there's 5 steps for a hypothesis test.